Okay students, so let's do question number 5. So this is the question. The fifth term, sixth term and the seventh term of geometric progression are given to be as 8k, negative 12 and 2k respectively. Given that k is negative, and we are asked to find the sum to infinity of the progression Okay, now we have the fifth term. Now r is a common ratio, so we know that there is a solution. We know that r being the common ratio is given by, so r is equal to sixth term divided by the fifth term. So the sixth term, what is that? Sixth term is given as negative 12 and the fifth term is given to be as 8k. So we have, what do we have? R is equal to negative 12 over 8k. Now also R can be rewritten as seventh term divided by the sixth term. So seventh term, what is seventh term? Seventh term is given as 2k divided by the sixth term is given by negative 12. So therefore r is also given as 2k over negative 12. Now this is 1 and this is 2. So what I'm going to do is equating 1 and 2 we get. So I have a negative 12 over 8k is equal to 2k over negative 12. I cross multiply, this will give me 144 is equal to 2k times 8k. So 144 is equal to 8 times 2 is 16k squared. Now this means I have k squared is equal to 144 divided by 16. Now 4 divides here 4 times, 4 divides here 3 times and 24, so that means 6, so 4 divides here 9 times. So therefore I have k squared is equal to 9, k is equal to root of 9, which means k is equal to plus 3 or k is equal to minus 3. Now we are given k to be as negative. Since k is negative, this means k is equal to negative 3. So you box that result. Now having got the value of k, now go over here. The sixth term, you see the sixth term is, or I would say the fifth term. The fifth term is 80k. Given fifth term is equal to 8k. So this means 8 times of negative 3 is equal to 24, the negative sign. So this is the fifth term. Now why am I doing this? Because I need to get the value of a, right? So fifth term is equal to a times r raised to the power of n minus 1. That will be that is how the order is. So this is going to be a times r raised to the power of 5 minus 1, that's going to be 4, is equal to fifth term. So we have got fifth term is negative 24 is equal to a times. Now the value of r has to be got, right? So how do we get the value of r? Now you see from 2, I'm going to show you, from 2 we have, what do we have? R is equal to 2k over negative 12, but k is equal to negative 3. So this means r is equal to 2 times of negative 3 divided by negative 12. R is equal to negative 6, negative 12. R is equal to 1 over 2. So this means you can just place a markation line there. So negative 24 is equal to a times r is 1 over 2 raised to the power of 4. So this is going to be 16, right? So a is equal to negative 24 times 16. So you multiply that. 24, 16, 6 4s are 24, 2, 12, 13, 14, 4 ones are 4, 2 ones are 2, 4, 8, 2 added with 1 will give it 8. So a is equal to negative 384. So you got the value. So now you have to actually get the sum to infinity. So therefore sum to infinity is given by s infinity is equal to a over 1 minus r, and a is negative 384, right, divided by 1 negative, my r is 1 over 2, so that's going to be negative 384 divided by 1 negative 1 over 2 is 1 over 2. You flip it, you get negative 384 times 2. 4 2s are 8, 8 2s are 16, 1, 3 2s are 6, 7. So therefore s infinity is negative 768. That's the solution for this question.